Okay, so in this video, we're going to talk about the second method for solving systems of equations, and that is by substitution. So what is substitution? It means to replace a variable with another value. Very important concept number one. You may substitute either equation. It is best to use the equation that already has an isolated variable. So if one of them already has an isolated variable, use that. If not, you're going to have to isolate a variable in order to use it. Okay, so find the solution for the system of equations. So here's our system. We have y equals 4 minus 2x and y equals 2x. So this one is an isolated variable. So we're going to take y equals 4 minus 2x and replace the y with 2x because the y is equal to 2x. So I'm going to take this 2x and put it here. So what do I have now? I have 2x equals 4 minus 2x. So I have no more y's, I have all one variable, and that's what we know to deal with. So we're going to solve this for x. So we're going to add 2x to both sides and get 4x equals 4. Divide both sides by 4 and find out that x equals 1. Well, remember, a system of equations, you need an ordered pair, an x value and a y value. So now I know my x value. So what do? I take this x value, plug it back in to either equation. Well, it's much easier to plug it into this one. And I always look for which equation is going to be easier when I plug it back in. You can pick either one. I choose the easiest. So y equals 2 times 1, because we're looking for y. 2 times 1 is just 2, so y equals 2. So my solution is 1 times 2, or excuse me, 1 comma 2. So again, what did I do? I found the isolated variable, y equals, and I plugged it in where the y was. Could I have had an isolated x and plugged that in? Absolutely. All that matters is that you have an isolated variable equaling something and you plug it in for the other one. Okay? So let's find the solution to the system 8x plus 6y equals 44 and x minus 8y equals negative 12. Do we have an isolated variable? Not yet. We're close right here. So in this case, we're going to have to solve for the variable before we can substitute. So if you come over here in this little red cloud, I solved for my x because that was easiest. I just added 8y to both sides and I found out that x equals negative 12 plus 8y, which is the same as 8y minus 12. But you'll notice that when I substituted in over here, that's what I put in. So now I'm going to take this x value, plug it in this equation. Now, if my equation had x written multiple times, I would plug it in every time I saw x. It only has it once though. So now I have 8 times 8y minus 12 plus 6y equals 44. I took this x value, plugged it in where I see x. So now I'm going to distribute my 8 to everything in the parentheses. 64y minus 96 plus 6y equals 44. 70y, I combined my like terms. This and this are like terms. 70y minus 96 equals 44. Solve your equation. Add 96 to both sides and get 140. 70y equals 140. Divide both sides by y. It's by 70, sorry, you get y equals 2. So I know my y value, but I need an ordered pair. So this time, instead of plugging in an x, plugging in a y. Again, pick the easiest equation. Well, this one is already in terms of x, so just plug in that 2 where you see a y. So now I have negative 12 plus 8 times 2, because remember, this was our equation. So I plugged in my 2 for where the y was. So I have negative 12 plus 16, so I find out that x equals 4. So I have found my solution to be 4 comma 2. So if I graphed these two equations, they would cross at 4, 2. Alright, so here's another example. 6x minus 2y equals 4 and y equals 3x plus 2. We got lucky on this one. We have an isolated variable. So take this y value, plug it in. So now we have 6x minus 2 times 3x plus 2. So we've got to distribute this time. So I get 6x minus 6x minus 4 equals negative 4. Well, 6x minus 6x, those are going to cancel, leaving you with negative 4 equals negative 4. Well, negative 4 does equal negative 4. It's a true statement. So you have all solutions. You don't have to finish solving. They're going to equal everything. They're going to end up being on top of each other, which we would have found if we had simplified it. All right, what about this one? X equals negative y plus 16. Look, we're going to have that isolated variable here. And 2y equals negative 2x plus 2. So I'm going to take this value here and plug it in here because I already have an isolated variable. So when I plug it in, once again, distribute so that I end up with 2y, because we have a negative times a negative, minus 32 plus 2. Combine your like terms, so we get 2y equals 2y minus 30. Now, when I subtract my 2y from both sides, I end up with 0 on the left and a negative 30 on the other side. 0 is never going to equal negative 30. So this is not a true statement. So there's no solution. So what this is saying is that these two lines aren't going to cross. So that's how you graph systems of equations using substitution.